All right, we are recording, and y'all feel good about yourself. And now I just got to hit this one, and we'll be ready to go. And it'll probably okay. There we go. All right. Now, when you go to the audio, you're just going to see this. This is all you're going to see. And you're going to hear my voice. And if you want to watch the video, then you just go to the video, because both of them will be the same. They'll be titled the same, except this one will be called audio and whiteboard, and that one will be video. And integers. Integers are basically the positive and the negative numbers. And I like to tell students, when you're talking about combining integers, combining means subtracting and adding integers. All you've got to remember is money. Because money is important to everybody. I don't care what you say. Well, money is not very important to me. You pay your bills, don't you? Okay, it's important to you. Now, if you're one of these people that like run around throwing daisies up and don't pay your bills, then we won't talk about that. But anyway, money is important to us because we pay our bills. We like to pay our bills. Huh?
Throwing daisies up.
Well, throwing up daisies, you know, butterflies and kumbaya and make love, not war, and you know, that type. Okay, not paying your bills. All right. But money is important, and I'll tell you why. I used to work at Walmart, and it only takes a woman a nanosecond to realize that she's been shortchanged. A nanosecond. I don't care how bad you think you are in math. It only takes a woman a nanosecond to realize she's been shortchanged. Guys, well, okay. About $5 later, we go, wait a minute, I had a $20 bill. She only gave me $5 back instead of 10. Okay? So, it's very important to some people. And all you got to remember is positive means you have money in the bank. I say pocket. Okay? You have money in your pocket. And we'll take a red marker and we will make this negative, means we owe money when you see a negative. Now a lot of people say, well, I had all these rules that I had to remember. No, you don't have to remember any rules except for these two and one other rule. And the other rule, I'm going to make it black. The other rule is if you have two negatives real close to each other, they make a what? If you have two negatives that close to each other, they make a positive. Now, if you remember those three rules with combining integers, you will not have any problem with doing these problems. Let me give you an example. -2 minus 4. Okay? First thing you do is ask yourself, what do you got? Well, here you owe $2. Here you owe what? You owe $4. Now, is there any way possible if you owe somebody $2 and you owe somebody $4, is there any way possible for you to get a positive $6? Nope. If you owe somebody $2 and you owe somebody $4, what is the outcome of owing two people money? You owe money. So the answer is going to be what? Negative, meaning that you owe money. And then you add the two together. 2 and 4 is 6. And that's your answer. It's as simple as that. But you would be surprised on how many students can't do positive and negative numbers because they got to remember so many dang rules. And with positive, with adding and subtracting integers, all you got to remember is those guys right there. That's all you got to remember. I don't care what kind of problem you got. Well, Hubert, what about this and that and this? Well, let's do another one. Let's do what does that positive 4 mean? It means you have $4 in your pocket. And this means you owe $3. Well, if you have $4 in your pocket and you owe Walmart $3, then what's the outcome of this transaction? You still have $1 left. Now, a lot can be, you can also think about Bill Gates. And I bring this up with a lot of my math classes. Or Zuckerberg, whatever his name is. Why did I pull Bill Gates and Mark Zuckerberg up? I don't know how to spell Zuckerberg, but what did he make? What did he come up with? Facebook. And what did this guy come up with?
Apple.
No.
Microsoft.
Yep.
IBM.
Yeah, Microsoft. He's the inventor of the computer, basically. And the other guy, whatever his name was, he was the inventor of the Apple computers. They worked together at the beginning, didn't they?
Yeah.
Now, what do these two guys have to do with positive and negative numbers? Well, if you're one of these two guys, what do you have in the bank?
Gazillions of dollars.
Lots of money. Did y'all see what this thing just did? Did you see that? Lots of money. It's going to crash again, but it's not going to mess us up. All right, lots of money. So, predominantly, these two guys, what are they? They are positive. In other words, everything that they have, every interaction that they have is going to come out to be positive because they got more money in the bank than they will ever what?
Need.
Yeah. In other words, let's say that they have, an electric bill for $300 for their house. Well, that's a bill, right? You owe $300, right? Well, their bank account is what? Gazillion, right? Infinite. What's bigger, 300 or infinite? Infinity is bigger. All right, so the sign of the larger number will carry the answer. In other words, if you're Bill Gates or Mark Zuckerberg, any transaction you have is going to come out to be what? Positive or negative? Positive, because they got a lot of money in the bank. Whereas Hubie is the other way around. Hubert is negative because alimony, child support, mortgage. I barely got money to live on. All right, it's okay. I'm happy.
That's why you're teaching summer school.
Exactly. No, I have to teach it, or it causes a bum puzzle with paperwork and personnel, and
really?
So a lot of people at Tri-County teach during the summer just to keep from having to go through that. It's kind of like when you go through and do something with your 401k, like borrow money against it. Sometimes it's just not worth it because you have to go through all of that paperwork. Same thing with tech. Anyway, why do I put a big negative here? Because I'm a negative person? No. because my money is already out of the bank account at the first of the month. All right? So most of my transactions come out to be negative because my bank account is low. All right? So what am I trying to get at? The sign of the larger number dictates the outcome, right? Outcome. Now that's just something you need to remember for later on, but Bill Gates, their bank account's full, so most of their outcomes are going to be positive, no matter how big their bill is. Whereas Hubert, most of his will be negative because his money is already gone before the first month. So the bank account assigns what the rest of your transactions are going to be for that month. So if you've got, let's say, $10,000 in the bank every month, and you have $4,000 in bills, then you got $6,000 or whatever I just said. I can't remember. 10,000, yeah, 6,000. You've got 6,000. It's going to be positive. So chances are most of your transactions are going to be positive versus the alternative. Okay. So let's do. Did I do that last one? I did, yeah. Sign of a larger number. Which one's larger? Positive. Positive. Sign of a larger number. Which one's larger?
-2.
-4 is larger. Well, the 4 is larger. That is larger, yes. But as far as quantity, we're just looking at the number. Don't look at the sign.
Sorry.
You're right. You are 100% right. But in this case, the 4 is negative, so the outcome is going to be negative. And that's just something for you to chew on. You don't have to know that. Just have it in the back of your mind. Let's do a nerd. -15 plus 4. Is this a Hubert bank account or is this a Bill Gates bank account? This is a Hubert bank account because this number means that I owe $15. This number means that I have $4. Yep, this is a Hubert bank account. So what's the outcome? Well, the number of the bigger number is, the sign of the bigger number is negative, so the outcome is going to be negative. Or you could say to yourself, well, he owes $15, he has 4. He's a loser. So what's the outcome? Dang it, I've got cows in the field. Better keep those cows in my name. All right? And you can do those all day long. Let's do one that might confuse you. What did I do to make that? I don't know what I did, but anyway. Make sure my little button's still blue. Yeah. All right, let's do this one. 14 minus -3. What's the sign of the bigger number? Positive. So your answer is going to be positive. What do you do? Wash that down with this when you get through it. I'm the same way with ice cream. When I go to Brewster's, I have to order a large water to wash down with the sugar. I can't stand to eat ice cream without something to wash it down with.
What's Brewster's?
This ice cream place on Mall Road, right beside the mall. You see it. You probably passed it 15 times. You just don't
I
see
saw
it.
Scoops, but they closed down.
Where's that?
It's in the PetSmart parking lot.
Oh,
Next to
PetSmart.
New York Pizza, but it's
I can't walk into PetSmart. It stinks. I can't stand it. It's like I can't stand taking my
live
cat
on
to
a
bed.
farm. Are you
I
kidding
cannot
me?
stand dog smell. I can't stand it.
But you live on a farm.
I ain't got no dogs.
But you have horses.
I have horses and cows, and I ain't got a problem with that. I just hate dogs. I hate the smell of them, I hate them, I hate seeing them, I hate touching them, I hate them. I'm a cat person. Cats are very clean.
No, they're not.
They're a whole lot cleaner than dogs, jumping all over you and lapping all over you. And
Yeah, because cat hair doesn't get all of your countertop and comes in.
no, if he doesn't, he gets popped. He gets popped or squirted with the squirt bottle.
My sister gets trained her cats that way.
Yeah. Mine will not get on the counter. He will not get on and he will not come around you when you have food because I squirt him with water. Whenever, the only time he comes around you is when he wants attention. That's it.
You put Vicks salve on the counter when you open, they won't get over it. It burns them in there.
Yeah, they don't like anything like that. I know they don't like mothballs.
Raider likes to lay in the sun.
Huh?
I prevent him from jumping on the counter because he lays in the sun. I'll open the blinds if he gets ready, like he's fixing to jump.
My windows come in on the carpet, and my cat just lays on the carpet like this because it's all warm and everything. Now that's smart. They ain't running around, running around in the wall.
I prefer my pit bull, thank you.
All right. So what do these two guys do?
They cause it to change.
They form a positive. Don't start thinking. All right. Don't start saying, "Well, why?" Just do what I say. Because if you start thinking, you're gonna get yourself confused. All right. So what's 14 plus 3? And you're done. Simple as that. There isn't any problem that you can't do thinking about money. There's none. Have y'all noticed that my circles all look like octagons?
Yeah, it's not making around.
I'm going to report that too. I'm going to figure this thing out before it's over with.
It's not satisfied.
Even if IT doesn't, I'm going to figure it out. Because I want to do this and not have to do all this. But anyway. All right, how about negative 4? And that's what they'll have. They'll have something like this. Plus 16 minus 3. All right, try that. Now remember, if you have two negatives pushed up together, what does it make it? So just use that rule. All right, the negative 4 turns into a 4 plus 16 minus 3. You have $20. You owe 3. If you have 20 and owe 3, the outcome is 17. So positive and negative numbers or integers are not difficult. It's just how they are explained and how the rules are explained. Do not learn any of the rules except for those. Now I'm talking about combining. That's positive and negative. That's adding and subtracting. I'm not talking about dividing and multiplying, because that's you got to remember is like and unlike. All right, so let's talk about those. And I don't spend a lot of time on these because 90% of y'all will be able to do them no matter what, because you remember these from pre-algebra because they were simple. When you multiply or divide integers, you just have to remember two rules. Like signs are positive, unlike signs are what? Are negative. So -2 times -4 is a +8 because you have two like signs. And like signs are positive. 3 times -5 is equal to -15. It's negative because you have a positive and a negative. Always remember this. Any of you that's ever jumped off a car before?
What?
Jumped off a car with battery cables, jumper cables?
I don't.
Okay? If you ever done that and you hook up the wrong colors or the wrong polarity, what happens? You get sparks. I mean, it really sparks. It goes, and it will burn up your battery as well as your alternator if you leave it on there, not to mention melt the jumper cables. Eventually it'll melt everything. So make sure you remember that. If you cross a positive and a negative, you're not going to get something good. And something not good is a negative. But if you put the red on the positive and the red on the positive and the black on the negative and the black on the negative, if you have negative, negative, and positive, positive, if you have like signs, then everything's going to be okay. And that means this. -3 over -3. We have like signs, so that means we're hooking it up correctly. +1. Now you don't have to put the positive in front of the 8, and you don't have to put the positive in front of the 1. I'm just showing you that like signs are positive. And of course the other one would be -4 over +2. And that's a unlike, so you're hitting you got a jumper cable on the negative and you're plugging it to the positive on another car, it's going to spark, it's going to cause damage. So that's negative. That's damage. Damage, damage. And that's how you do positive and negative integers. 5.2 is really not a big deal. I do see a lot of people not understanding the first part, which is combining, and that's where a lot of people have problems throughout all of their math career. They've always had problems with positives and negatives because of so many rules that has been presented to them, and all you got to remember is 5 rules. Positive means money in your pocket. Negative means money you owe. 2 negatives together is positive, and like signs are positive, unlikes are negative. And that takes care of all of your rules. .3. We're going to spend some time on 5.3 because 5.3 is where we talk about fractions, I believe. Now, the most time we're going to spend is adding and subtracting fractions. And the reason we're going to spend so much time on it is because that's where people have the biggest problems. People don't have problems multiplying and dividing fractions because multiplying and dividing fractions most people can do without any problem. But the addition and subtraction of fractions is where everybody, kind of like integers, addition and subtraction of integers. Well, with fractions, you have the same thing. Addition and subtraction of fractions is the biggest problem students have. In order to add or subtract fractions, what do we have to have? To add or subtract fractions, you've got to have a common denominator. Now, in 5.1, what was the first number called? The greatest common divisor? We need the least common what? We need the least common multiple. In 5.1, it was called the least common multiple. Now, as I showed y'all on that preview of common attractions, when I said, okay, you don't have to write this down, and I gave y'all a problem, a fraction, well, that's what we're going to be doing. I'm going to start off with something simple. Let's go with 1/2 plus 3/4. Now, you can do it this way, or you can do it like this, 1/2 plus 3/4. Okay? That is not going to stop the earth from revolving. Okay? Whether you do it horizontally or whether you do it vertically, I don't really care. Okay? The biggest thing is that you have two different what? Denominators. So, you go back to your handy dandy way of finding 2 and 4. 2, 3, 5, 7, 11, and sometimes 13. 2, go in there, 2, 1, 2, and then 2, 1, and 1. We have our 1s. So what is our common denominator? 4. And what I say, 1 over 2 plus 3 over 4 is equal to what? Well, we've got to get a common denominator. There's our common denominator, 4. And once you get the common denominator, the second thing you do is convert the numerators. So 1, 5, common denominator. And I did that right there. 2. After you find the common denominator, you have to convert the numerators. So here we go. 2 will go into 4 2 times. 2 times 1 is 2. And we need to write goes into, and then 2 times 1 is equal to 2. 2 goes into 4 2 times. 2 times 1 is 2. 4 will go into 4 1 time. 1 times 3 is 3. So once you convert the numerators, add / subtract, whichever the case may be, numerators, carry denominator, 5, reduce if possible. And 2 plus 3 is what? Your answer is 5/4. This always brings up the question. Well, Hubert, why don't you write it as a mixed number? You need to reduce it. Well, you've been taught wrong, because reducing is not changing it to a mixed number. Reducing is simplifying. Does everybody agree with that?
Yes.
Okay. If reducing is simplifying, what is the definition of simplification? I asked my one of my Clemson professors at one time, and he says the number of times your paper hits the pencil. I mean, the pencil hits the paper. Okay? So, 1, 2, 3, 4, 5. Or 1, 2, 3, like that. All right, 5 fours. I counted 3 here, I counted 4 here, or 5. Now how about 1 1/3, which is 1, 2, 3, 4. And I'm just using that one flow. 1, 2, 3, 4. 1, 2, 3. This is 3 times. This is 4 times. But you're telling me that this is reducing? No, it's rewriting. If you've ever had a teacher tell you it's reducing, then they either didn't know what they were talking about, or you must have got something mixed up, because it's not reducing. It's rewriting. When do you use a mixed number? You use a mixed number whenever you have a unit of what?
Measure?
Measurement. It's the only time you use a mixed number. But what about 4 over 2? Well, 4 over 2 is not a mixed number. 4 over 2 reduces down to 2. That's a totally different animal than 5 fourths. 4 over 2 is not a mixed number. 4 over 2 is an improper fraction that reduces down to a what? A whole number. This is not that. Yes, ma'am. I'm sorry, what? Add / subtract. Oh, carry denominator. And number 5 says reduce if you can. All right, let's try nerd. Oh, sorry. There you go. Hurry. God.
Look, it's hard to write when you're standing on the board.
What, are you saying you can't see through muddy water?
Yes.
I'm very muddy.
Jeez.
Now, a lot of people say, well, Hubert, that's simple. I know 4 and 2, the common denominator is 4. Some people put 8 because they don't know how to find the common denominator. They just multiply them together. The only time you multiply the 2 denominators together is when they are both prime. When they are both prime, or one is a multiple of the other. And then you just use the larger of the 2. 2 is a multiple of 4, so you just use what? 4. You don't multiply 2 times 4 because they're 2 composite numbers. Or 4 is a composite number. 2 is prime. Now, if you have 3 and 7, the common denominator is 21. Period. Because those are 2 prime numbers, and you can't do anything with 2 prime numbers. So let's do a couple more. 3 over 5 minus 1/2. I'm going to let y'all take a second and work on that one. So this one does have a prime number, but it has a composite. So chances are you can just multiply these 2. Because 2 will not go into 5. And both of them are prime. I don't know why I was saying 10. That's why I said one of them is prime. But just to make sure, 2, 5, 2, 3, 5, 7, 11, sometimes 13, 2, 1, and 5. 5, 1 and 1. There's your common denominator. 2 times 5 is 10. So 10 is your common denominator. 5 will go into 10 2 times. 2 times 3 is what? 2 will go into 10 5 times. 1 is piece of cake. The secret is this guy right here. Because I'm not going to give you a bunch of these on the test. I'm going to give you some that are a little bit more challenging. So let's try one. Let me see if I can find one in the homework. Got to pull it up. Oh, I just want to come over here and sit down.
It's not hybrid.
What?
I'm not learning. I'm slow. Don't worry about
That's all right. We all have our bad days.
it. Move it up.
What chapter is this? 5? This is 5-3. I'm just going to pull some. I think you might want to add some. Be nice to add a couple, you know. I guess not. Maybe I'm. There we go. Mm-hmm. All right, try that one. This one says 1/9 plus 1/6. Oh, that's easy. 6 times 9 is 54. Wrong. If you just want to work extra hard, you know, that's fine. That's what a lot of NASA engineers do. Common denominator there is 54. You just multiply 9 times 6. Well, they not only do they not know what they're doing, they also might get it wrong because they have to reduce 5 times more than you do at the end of the problem. Now, the first thing I'm going to do is I'm going to, excuse me, yawn. I'm going to turn it around, 1/6 plus 1/9. And the reason I did that is because because I just don't like to have the 9 in front of the 6. That's just me. And yes, I can be quirky. Usually I'm not quirky, but I'm quirky about that, okay? So, where did my thing go? There we go. And I can change it around as long as I carry the sign. This is a plus, and that's a plus, so I can change it. 1/6 plus 1/9. Well, I gotta have a common denominator of 6 and 9, right? 2, 3, 5, 7, 11, and sometimes 13. So 2 or 3. That'd be a 2 and 3, 2, 1, 3, 3, 1, and 1. So we got that. So there is our common denominator. What's 9 times 2?
18.
So 18 is your common denominator. So the guy that said 54, he was way wrong, because 18 is a whole lot smaller to deal with. A whole lot easier to deal with. And you feel good about yourself. So 6 will go into 18. How many times? 3 times 1. And you know what? Even if you don't know how to do math, all you got to do is say 6 will go into 18. We'll take out the 6. How many times? So even if you don't know your multiplication tables, you can still do it by marking out what you're taking into it. 6. Take out the 6 3 times. How many times will 9 go into 18? We'll take out the 9. How many times?
2.
Ain't that something? And your final answer is 5 what? You see why people should be able to do fractions and integers? It's not that difficult. And just so y'all can see that I know what I'm doing, I'll type in a 3 here so we can check our answer and make sure there's not a 54 in the bottom. Well, I always used 50. Well, I just got out of it. I suck. All right. Let me do it again. What number was that? There it is. Nope. Well. Oh well. Miss Harper, why'd you let me do that? Okay, let's do a nerd. Oh yeah, there's a test question. Yep. Try it. Oh, Lord. Yes, Diva. I'm sorry. Yes, ma'am.
That's okay. I'm on the second row and I can barely see it.
Oh, God.
It's too dark.
Well, I have to get it dark so I can see the video.
You keep it dark and making us fall asleep, so
It's all my fault.
sorry.
I'll blame Bush. That's what you're supposed to do when something don't work your way. Blame Bush. Right?
Before we leave, I had a question about one of the problems that I did in this chapter. Can we go over it before?
Yeah, in fact, I'll look at them after I do this problem.
I mean, I did it, but I don't understand how I did it, so I have to do that before the test.
Oh, don't say test. Everybody will start doing, what's this, what's this, what's this?
Like
What's due date, what's due date?
I'm not asking that question, you told us not.
Oh, listen, don't matter what I tell y'all. I get people emailing me every day, when's test, when's test, when's due date, when's due date? It's like they're gonna explode, like the squirrel on, you ever seen that squirrel on the hedge?
You came over to
Yeah,
yeah.
bouncing around, that's what it reminds me of. Okay, so let's go with 10, 50, and 125. 2, 3, 5, 7, 11, and sometimes 13. Of course, we're going to go with 5. It'll be a 2, a 10, and 5 will go in there, what, 2 times, and then 5, 25. 2, 1, 5, 25, 5, 1, 1, 5, 5, 1, 1, 1, and there is your common denominator. Now, remember, what I've always told you, if you can find a 10, use it. Is there a 10 in here? Right here. And then what's 5 times 5? 25 times 10? 250, Hubert. That's right, class. And again, you don't have to be a rocket scientist. All you have to do is just take out this number. Where is 10 there? Well, it's right here. Take this out. How many times will 10 go into 250? 25 times. 25 times 1 is 25. How many times will 50? We'll take out 50. 5 times 10. How many? 5 times. 5 times 39? Well, let's think. 5 times 40 is 200. So if 5 times 40 is 200, then 5 times 39 is 195?
Yes.
So 195. And that will go in there 2 times. That'd be 202 plus 200. That's 402 minus 5 is going to be 393 or 397. 397, right? Somebody check that for me.
Yes.
Is it 397?
Yes.
397 plus 25, or 400 plus 25 is 425. Minus 3 is 422.
Yes.
So you get 422 over 250 and reduce. I know that 2 will go in there. I'm just going to do it. Let's see, 2, that'll be 211 over 125. I think probably that's going to be your answer, but we'll check it and see. Have you noticed what I didn't use on this problem?
Calculator.
Unless you can't do elementary math. Now you're starting to see why people can't do fractions. And you can do these all day long. Look there, we got it right. Them big numbers, and we didn't even use a calculator. And what's going to happen is you're going to do some of these other problems and you can't believe you can do them without a calculator. So let's go to I'm going to put this one on freeze so y'all can look at it while I go to homework problems. 155. Where's my email? There it is. Oh, Lord. 155. There you is. Absences. Let me guess. You've been absent Monday. Well, we didn't have class Monday, but I have to go through and put in attendance for Monday. This college has done gone insane. Let's see, what chapter are we on? 6 point what? 5.3. Why are all these from 6.7? That's 102. Somehow I've gotten my classes mixed up. I've got to fix them. That's not right. There we go. Okay, 5.1. I'm looking for yours, Miss.
I have a question on 5.3.
Well, I'm looking for it. Where is it?
I don't know, I did it.
When did you send it to me?
No, I didn't send it to you.
Say again.
Oh my God.
Why not? All you gotta do is hit a button.
Because I got the problem. I finished it. I just don't know how I finished it. So I just wanted you to go over
Okay,
it.
I'll have to go look it up.
No, I can tell you.
I
which
don't
one it
know.
is.
Why do I not get y'all to do that? I told y'all this story. When I taught my first semester, I didn't tell y'all this story.
This is number 3.
Huh? This number 3. I taught a class, 101, 102. The student brought me a problem, and handwritten, and had the answer written with it. And I did that problem 5 or 6 times. I could not get the answer to come out right. Do you know why? They wrote it down wrong. I'm not saying you wrote it down wrong.
No,
I just do not do handwritten problems anymore. So, I will go to your homework
But
and
got
I will
the
pull it
question
up.
Right.
Okay, well, I'm still going to write it down.
Well, no, I understand. I want you to.
Let me pull it up.
I mean, you could do an example of the problem. I don't care. I just
Nope,
want to know
you don't
how
do
I
your
did it.
problem.
Jesus Christ. Alright, whatever. I don't argue with you.
I mean, all you had to do was hit a button, that's all. But that's all right. That's all right.
Oh, whatever. I don't remember which number it was. That's why I can't tell you. I'm sorry.
Oh, anvil banana. Anvil banana.
Is that supposed to mean something then?
Yeah, some students can break an anvil with a banana.
I'm not trying to be difficult here.
I know you're not. All right, which section is it?
It's 5.3.
5.3. And let me look through. Do you remember? You don't have any idea which one it was?
It was like 4.08 with a line over it because the 8 was.
Yeah, we hadn't done that one.
Repeating?
We hadn't done that one yet.
I know, but the class is going to end in like a half hour.
What? Give me a half hour?
You said you were going to look through the homework. Why are you being so
gosh.
difficult?
You're such a wife sometimes. Just kidding. That's a joke.
Well,
Let me
that's
find it.
good because I've never been married, so I guess I got it down
Oh,
pretty
okay.
good.
Yep. All right. Like that one?
I don't know. It's not on the board.
Oh, I'm sorry. I'm being difficult.
For a reason, probably.
Is that what you're talking about?
Yes.
All right. Write that problem down. This is like number 15. 5.3, number 15. Go ahead and write it down. Now, this is kind of a problem that you don't see very often. What they're wanting you to do is find a improper fraction that's equal to a repeating decimal. I know.
It gave me such problems last semester.
You didn't see the memo on this? There was a memo sent out on this problem.
I'm sure there
It
was.
says this problem is to make Miss Fifield irritated.
No, it made me pull out my freaking hair is what it did.
All right, so I'm gonna say x is equal to 5.05 repeating. That's what I'm gonna say. X is equal to that. And then I'm going to multiply both sides by 100.
Why?
Because I'm going to set up an equation that I can divide and find. I need to get the repeating numbers. I need to get them to cancel, because the repeating numbers is what's causing the problem. So this is what we're going to do. X is equal to 5.05 repeating.
And you're using 100 because it's in the hundreds place, right?
Yep, that's the best way to do it, yes. And I'm going to multiply by 100 on both sides. And that's going to give me 100x is equal to 505.05 repeating. Now, I've got two equations. I've got this one, and I've got this one. I'm going to subtract the small one from the large one. So 100x is equal to 505, 0.05 repeating, minus x minus 5.05 repeating. So I took this one away from this one. Now when I do that, what happens to the repeating decimals? It goes away. So I get 99x is equal to what?
500.
And now divide by 99 and reduce if needed. That's basically your answer. Now you need to write this down and you need to put it in your notes on how to do it, but you might get one on the test. That's about it. I don't spend a lot of time on this. What you're doing, this, I haven't done anything here. All I did was say x is equal to this. That's all I did. Didn't do anything. Here, I multiplied both sides by 100. The reason you do that is because you want to get this to fall off. And that's how you do it. You subtract the two from each other. Not doing anything illegal. 100 minus 1 is 99. So not doing anything that's changing the numerical value. All I'm doing is subtracting this equation from this equation. And what it's doing is it's knocking this off. And you're left with this.
And then 91/18 is the reduced answer.
Whatever you say, yes. I didn't do it, so whatever you say. Now, take your calculator and take 500 and divide it by 99 and see what you get. You should get this.
Thank you. For being difficult, but thank
Yeah, I know. Well, I try.
you. Me too.
All right, let's go over another homework problem. I can find some because the other one's 102. I don't know how they got in there.
Can you just leave this in?
Yeah, I'll freeze it for you so y'all can write it down. I'll be finding another problem. Okay, we're in, I don't know how this got. Cynthia Wilson is not in this class. I must have it set backwards. Yeah, because that's 102 also. I got something set wrong. Dadgum. One student sent me like 5,000 problems. I think I'm doing their homework for them. This is in another class. That's 155. That's good. That's 102. It needs to be over here. That's 102. It needs to be over here. 102. All right, that's 5.4. We haven't got to 5.4 yet. That's 5.1. .7. Okay. All I've got is 5.1. I got one question out of 5.3. This is number 59, number 15. 59, number 15. Same one. We'll do this one for good measure. All right, try that one. 2.03 repeating. 2.03 repeating. All right. X is equal to 2.03 repeating. So 100x is equal to, well, if I multiply, that'd be 2.203.03 repeating. Right?
The repeating going over the 3, right?
Yep. I'm looking at it, looks kind of strange.
Because you have the repeating over the 0, 3 and not the 3.
Oh, that's why. Sorry. What? Is that what everybody was saying?
Yeah.
Okay, thank you. All right, so now we have, so I'm going to bring this down and I'm going to subtract it, minus x, minus 2.03 repeating, and that goes off, and then 203 minus 2 is what? 201. 201 is equal to 99x. And divide by 99 and reduce as needed. And you can always check it by taking your calculator and dividing 201 by 99, and you should be able to get the repeating decimal 2.03. Okay? And we'll type in 3, that way everybody can see the answer. And I trust it's 61 divided by 30. I guess you're dividing by, let's see, 30. Will 30 go into 99? I must have something wrong. I really didn't like the way this looked. Usually it's supposed to be 3.03 minus 3.03, but
It's 202.03.
that's what it's supposed to be. But when you multiply, you move it 2 places to the right, it's 203. I think I've done something wrong. Wait a minute. What was the previous problem? Was the 3 repeating, or was the 0, 3 repeating, or what was the last problem we did?
It was a 5 repeat. It is
Okay.
0.05, 5 repeated, 5.05.
Okay. The reason that is this number was the same as that number. That's why it worked out, but I still should get the same thing. I don't know why I'm not getting the same thing. Because 30 won't go into 99. 3 will go into 99 33 times. But it's not coming out the same. Let's see what they did. Because I don't know. Close. Oh God, I had to do that, didn't I? I don't know, just freaking do it. Okay, 10. I did it by 100.
Oh.
Wait a minute.
Because it's, no, never mind.
It says directly to the right of the decimal. Oh, because the 3 is repeating. It just worked out on the last one. The 3 is repeating, so that would be 20.3. So you multiply by 10 in on both sides. It would be 10. I'm sorry.
Now, why is it 10?
Because the 3, you need to get the 3 repeating instead of the 0.0. I mean, you got to get rid of the 0. The 0 is in the way. And the reason it worked out on the last one is because the 5 and the 5 were equal. This one won't work because the 2 is not equal to the 3. And the last one, the 5 is equal to the 5, and that's why it worked. So the best thing to do is multiply by 10, and I'll show you why if I could ever get this thing to do it.
We're trying to get rid of the number in the 10 spots you got.
Right. Yeah, right here, this 0 is not repeating. Y'all see that? It's not repeating. So you've got to get the repeating number by itself. So multiply by 10, and that's why I messed up on the first one. But the reason it worked on the first one was because this number and this number was the same. So let me go over here, and I'm going to multiply. X is equal to 2.03, and 3 is repeating. Now, this is not going to do me any good because I got to get that 0 over here. So I'm going to multiply by 10. And that will give me 20.3 repeating. Now I can multiply by 100, or I can, multiply by whatever you want to, because that 3 is going to be repeating, and there's no 0 over there now. So 100 or let's see, you don't have to necessarily, you could actually take these two away from each other. You don't have to multiply by 100. You could take it away.
So you still subtract 20.
Yeah, I wouldn't, because then you'd have this mess. I'd go ahead and multiply through, and that's what they're doing right here. See right here, 100. If there is one repeating, multiply by 10. If there's two repeating, like this, 2.10. See the two numbers right here? If they're both repeating, then you multiply by 100. If it's just one repeating, like this one, then you multiply by 10. And that's what they're doing. Both sides of the equation multiplied by 10. Because you're trying to get rid of that repeating decimal. So multiply both sides by 10. And then there's the 100 right there. So go ahead and multiply that. Multiply both the n, this equation right here, multiply it by 100. So that'd be 100x. I don't know what happened to my pen. Just went to skinny. 100x. I'm about ready to quit. Is equal to, and multiply by 100. So that'd be 203.3 repeating. And now you subtract these two. And 100 minus 10 is what? 90x. And what happens to the 3's? They cancel. And 203 minus 20, somebody give me that. What's 203 minus 20? Be 77? 177? I don't know. Somebody tell me.
Do you do the 203
203 minus 20.
minus the original?
No, 203 minus 20. Right here. How much?
183.
183. And then divide by 90 on both sides. And there's where my 30 comes from in the answer. So divide 3. What's 3 into this? 61. So it'd be 61 over 30. Is that what the answer was? So my mistake on that one. So just remember, when you're doing these problems, remember this right here. It's somewhere right here. Like I say, I don't want you spending a lot of time on these. I want you to do them, but don't spend all afternoon doing them. You need to be working on the fractions and the integers, because that's what's going to make up a lot of your adding and subtracting especially. I think I'm through today. Let me go ahead and shut down everything. Hold on just a minute before y'all start running out of here.